Hello and welcome to episode 4 of our series Back to Basics Business Technology Platform. In this episode we will focus on a very interesting topic in the platform environments, and that is the data movements. Until now we have seen different database technologies with their own characteristics and serving all different goals. For historical reasons, the application landscape has been architectured in silos, showing clear dependencies between application and their database repository, creating archipelagos inside the IT ecosystem. Meanwhile, the need of a more efficient integration rose when organizations understood the benefit of fully integrating the business processes and their related data sets, inducing the need of data movement to interrelate the silos between them. Data movement does what its name suggests, and there are multiple ways of doing so and of avoiding doing so. The most common ways of moving data are via data integration, replication, federation, and stream. Data integration is a set of capabilities that allow data that is in one place to be moved to another place. The technologies involved include ETL, extract, transform, and load, and ELT, load the data before you transform it, and variation thereof. An ETL process is usually executed by an engine extracting data from a source, manipulating or transforming the data inside its own memory, and loading the results into a target database. The engine is rule-based, meaning we can program actions to perform on the extracted data. The main actions an ETL engine does are validation, enrichment, cleansing, and transformation. Validation can be very simple, like ensuring correctness of data type, or quite complex, like validating a reference to a customer must exist in a reference table. Data enrichment refers to the process of appending or otherwise enhancing collected data with relevant context obtained from additional sources. Data cleansing is the process of detecting and correcting corrupt and inaccurate records from a record set. Data transformation is the process of changing the format, structure, or values of data, making sure they will match the target table structure. It rapidly appeared the target database engine and its associated SQL language was often more efficient than the ETL engine in processing the different validations and other transformations over the extracted data. Therefore, the concept of ELT, extract, load, and transform, arose to allow delegating partial, if not all, actions to the database engine. In the SAP HANA platform, the integration engine is called Smart Data Integration. Data replication, on the other hand, along with change data capture and associated techniques, is essentially about copying data without any need for transformation. The replication mechanism assumes that the schema between the source and the target tables is coherent. There are two main families of replication systems: trigger-based and log-based. A trigger replication is based on the creation of SQL code associated to modification events, insert, delete, update, in the data source tables, so that when this table receives a change to apply, the SQL code is triggered and sent the same change to the destination. In log-based replication, an engine called replication agent monitors the transaction log of the database and extracts the data impacted by a particular transaction. This portion of the log is transferred to a rule-based replication engine that will decide what to do with it. Simply replicate the new data as is, filter them, distribute them over multiple databases, transform or enrich them, all based on rules defined in the engine. Log-based replication is started only once for all changes induced by the transaction, while trigger-based replication starts for every row impacted by the transaction. Log-based replication respects the boundaries of the original transaction, while trigger-based applies the changes on a row-by-row basis with no transaction context. In the SAP HANA platform, the replication engines are called SLT, Landscape Transformation, or SAP Replication Server. It is not always required to physically move the data from one database to another. Sometimes accessing the data remotely is performing enough to execute the queries from the users. Technologies for the avoidance of data movement include both data virtualization and so-called HTAP, hybrid transactional and analytic processing, environments where a single database supports both transactional and analytic processing, as well as analytics. With HTAP, as everything is performed in one place, there is obviously no need for data movement. This is typically the case of SAP HANA. Data virtualization, sometimes called data federation, makes all data, regardless of where it's located and regardless of what format it is in, look as if it is one place and in a consistent format. Given that you have all this data looking as if it is in a consistent format, you can then easily merge that data into applications or queries without physically moving that data. This may be important where you do not own the data, or when you cannot move it for security reasons, or simply because it would be too expensive to physically move the data. Nevertheless, it's important to keep in mind that there is no way to join data without having data in the same physical memory. Therefore, mixing data from heterogeneous systems requires a data transfer between the two database engines. With a very large data volume, this may seriously impact the performance. In the SAP HANA platform, the virtualization engine is called Smart Data Access. Stream processing is typically about moving large quantities of data in real time, often without requiring any transformation of the data, though relevant products typically have some processing capabilities. For example, for moving log data or ingesting sensor data. These platforms may also be used to support streaming analytics. Stream processing platforms typically have some processing capabilities, so it is possible to perform quite complex transformations using these products. However, their main goal is to allow the movement of large volumes of data, typically such things as sensor data, stock ticks, web clicks, or log data, where there are low latency performance requirements. Unlike any of the technologies discussed before, they are not usually used for moving data from one database to another, but rather from sources that are more disparate and less structured. The base concepts are quite simple to understand. With the streaming engine comes a set of input and output connectors. The input connectors are responsible for collecting the data, sometimes called events or messages, from the sources. The output connectors are responsible for distributing the data to their final target. In the middle, the streaming engine knows the rules to apply and reacts to the event or messages. In the SAP HANA platform, the streaming engine is called Smart Data Streaming. Today, there are three very popular approaches to data integration: data lakes, data virtualization or federation, and data hubs. All three approaches simplify self-service consumption of data across heterogeneous sources without disrupting existing applications. We already covered the data federation topic in this video. Let's briefly introduce the other two, even if they will be elaborated in another video. A data lake is a storage repository that holds a vast amount of raw data in its native format, including structured, semi-structured, and unstructured data. The data structure and requirements are not defined until the data is needed. A data hub is a hub and spoke approach to data integration, where data is physically moved and re-indexed into a new system. A data lake will run the same process but will always keep the source format. Data is ingested in as close to raw form as possible without enforcing any restrictive schema. To become a data hub, this system would support discovery, indexes, and analytics. Data lakes do not index and cannot harmonize because of the incompatible forms that they will hold. The prime objective of a data hub is to provide a centralized and unified data source for diverse business needs. SAP Data Intelligence is a comprehensive solution to deliver data-driven innovation and intelligence across the enterprise, unifying scalable enterprise artificial intelligence and intelligent information management. It includes data orchestration, machine learning, and metadata management to drive data innovation. Now that we have understood the different capacities, capabilities, and ways of moving data from one database to another database, I will see you next time on the next episode focusing on the governance of the data. Thank you. Bye bye. See you soon.